Hello AP Statistics students. In this video, we are going to still take a look at a one sample z-test. But this time we're going to take a look at one that requires two tails instead of just a one tail. So we were going to do this the hard way first, as usual, to give us the context of the calculation. But then, of course, we're going to do this on the calculator. And then we're going to do it on the calculator forever and ever after that, essentially. So here is our question. According to the Centers for Disease Control and Prevention, all right, the CDC, 68% of high school students have never smoked a cigarette. All right, that is our null, right? Yan Hong wonders whether this national result holds true in her large urban high school. For her AP Stats class project, Yang Hong surveys a simple random sample of 150 students in her school. She gets responses from all 150 students, and 90 say that they have never smoked a cigarette. Is there convincing evidence that the CDC's claim does not, interesting, that's the difference there, does not hold true at Yang Hong's school? All right, so I'm hoping you saw a slight difference there in the question there as usual, as we do our stating process here. So our null hypothesis, I guess now we're supposed to say something before that, right? All right, we are going to test so our null hypothesis is that the proportion here was 68%, just like the CDC said. Our alternative, all right, so that it does not hold true. So we don't think it's greater or less. We just want to know if it's not what the CDC said it was. And that's how we know this is a two-tail test. It could be bigger, it could be smaller. All right, that's what it means to be not equal to. All right, one more thing that we're supposed to put into the state part that I think I forgot in class. A little more context. Where P is the true proportion of high school students at this school who have never smoked a cigarette. All right, a little bit of context for what P is. And then we are going to do with an alpha equal to point, where did it say? No, I guess it doesn't say. So let's pick one, shall we? Let's go 0.05. Let's pick an alpha of 0.05. I don't think it says there. Usually they tell you what to do. All right, now time for the other three steps. So first, our plan. What are we doing here? So this is, even though it's going to be a two-tail, we still only have one sample. Z-test for P. Now we got to test all of our conditions. So first, do we have the random condition? All right, somewhere in here it says, yes, we took a simple random sample of 150 students. Yes, we took a SRS of 150 students. So that one is met. All right, do we have the 10% condition? Yes, it is safe to assume that our sample of 150 students is less than 10% of. All right, now this is the one I think we're still kind of struggling on. You cannot just say the population. You need to be more specific. What is our population here? Okay. We are sampling from Yanhong's school. So that is our population from her school. Did I spell her name wrong? Yep. I'm not sure why I put a U there. All right. It's from that one school. Not a nation, not a country, not the world, just her school. And that's a safe assumption that her school is bigger than 1,500. That's not that bad. Be careful with that. You can't just say the population. And the large counts condition. All right, I think I might use my pencil for that. So the large counts condition, n times p and n times q. So it is 150 times, remember we use the proportion from the null hypothesis, 0.68. And then we do 150 times q, which is 0.32, right? Both of those need to be bigger than 10. Let's make sure they are. 150 times 0.68 and 150 times 0.32. They add up to 150. Make sure you do it right there. So 102 and 48. Those are both greater than or equal to 10. Our large counts have been met. The conditions for inference have been met. All right, now we can actually do our one sample Z test for P. So let's do this the long way so you can, again, get a good idea of the context of the calculations, but then we are going to do it on the calculator. So remember, we do all those conditions, and one of the consequences of that is that we now have a normal sampling distribution for p hat, assuming the null is true. So we have this normal distribution here, right? Where the center is the null, 0.68. All right, our population proportion is 0.68, or at least that's what we're assuming is true. Our standard deviation is the square root of 0.68 times 0.32 divided by 150. So our standard deviation is 0.038. All right. Now, our p hat gives us some evidence against that null, doesn't it? Our p hat was equal to, let's see, 90 said that they had never smoked it. So 90 out of 150. Where's my calculator? 90 out of 150. So 60%. So somewhere over here is 60%, right? Now, why does that give us some evidence against the null hypothesis? Because that is 8% away. So all of these possible samples right here would give us some evidence that it's not 68 because they're far away from 68. Well, what other numbers are far away from 68? These ones over here, right? The mirror image of it. So what is the mirror image? So it's 8 away. So we have to add 8. So that would be 0.76, right? So anything above 0.76 or below 0.60 would be giving us evidence against the null hypothesis. Okay? What are the chances that we get a sample below 0.60 and above 0.76? That's what our p-value, that's what our p-value is going to be. So we have to calculate these two, the sum of those two areas. So we're going to do a normal CDF. Now, how are we going to get these two tails? All right, you can see the two tails here. How are we going to get the two tails here with a normal CDF? Well, it's not as hard as you might think. I don't think anybody's calculator has a tail option for a normal CDF. You have a between, but not a tail. So what are we going to do? Well, thankfully, this curve is symmetric. So this area is exactly the same as that area. So we're just going to find one and double it. All right, we don't have to try to do both. Just take one, double it. The curve is symmetric. So it doesn't really care if you do the left or the right. So I'm going to do the left. So we're going to take a mean of 0.68, a standard deviation of 0.038, a lower of a negative, 10,000, and an upper of 0.60. Then we're going to take that number and simply multiply it times 2 to get the other tail. So we are going to go stat. Oops, no, we're not. We're going to go distribution, normal CDF. A really big negative number is the first one. That looks good. My upper is 0.60. My mean is 0.68. My standard deviation is 0.038. We get 0.017, and so we're going to multiply that times 2. 0.035. So my p-value is 0.0, I just forgot it, 0.35. Again, that's the hard way to get the p-value. But again, I want to reinforce that this is a sampling distribution of possible samples, assuming that the null is true. Now, for the easy way, you can do this on the calculator. You may have seen it when we were practicing earlier. Stat, test. This is a 1 prop z test. I'm going to type in everything that we know. So my null is 0.68. There were 90 out of 150. And then I want this one, not equal to. That is going to be for the two-tailed test. Real easy, right? My alternative was that it was not equal to the null. Let's draw that. And you can see it colors in the two tails for me. That's the area we're finding. And take a look. The p-value is 0.035. Done and done. So again, that's the easy way. You are certainly allowed to use the calculator on this. All right, time to conclude. So remember, it's been a while. Our alpha was 0.05, wasn't it? Oh, so my p-value is less than alpha. So because our p-value of 0.035 is less than alpha, which is equal to 0.05, we reject the null hypothesis. All right, there's my stats. That's not enough, though. We need our context. We have convincing evidence that, all right, context, the true proportion of high school students at, oh, did I spell her name wrong again? Yanhong, Y-A-N. All right, we have convincing evidence that the true proportion of high school students at Yanhong's high school that have not tried cigarettes. Oops. Wow, can I not spell cigarettes? Good job, Bolt. Is not, wow, I still didn't get it. Yay, right click. Is not P equals 0.68. All right, the null hypothesis. It is not 0.68. There we go. Not too bad, hopefully. There's one more thing I want to talk about. Sorry, I know you thought you were done, but I would like to connect this back to confidence intervals. I'm hoping you see a connection here to the confidence interval, especially with the two-tailed test here. Doesn't that kind of look like the confidence interval? It kind of is. So we're going to create a 95% confidence interval using the sample statistic. Let's say we didn't have the null hypothesis and all we had was Yanhong's sample of 90 out of 150, which was 60%, right? Where do we think the true mean would be? So we would do 0.60 plus or minus, and my pen is dying on me or something. There we go. Let's see, a 95% confidence interval, 1.96. Now, Bolt, why did you do a 95% confidence interval? It is tied to the alpha. All right, and alpha is 5%. That means we're testing to see, hey, is this part here bigger than 2.5%? And is this part bigger than 2.5%? That's essentially what we're testing here. Is this fitting inside a 95% confidence interval? That would give me 5% of error total. Not a perfect way of thinking about it, but I think it helps make a connection. Then we do our, let's see, our standard error here, right? 0.60 times 0.40 divided by 150. And we find this confidence interval. Of course, we can do that the easy way, right? Stat tests. Where is it? One proportion z interval, where x is 90, n is not 150, and our confidence level is 95. And so we get 52% to 0.678. Ooh. All right. 0.52 to 0.678. So we are 95% confident the true proportion is between 52% and 67.8%. That means we would be surprised, we would reject any true proportion outside of that. We would be very surprised if the true proportion was outside that interval. And hey, the null was outside that interval. The null was 0.68, which is why we rejected it. All right. I hope you can at least see there that a confidence interval and a two-tailed test are definitely related there in a bit. All right. Our null was outside the 95% confidence interval, So we would have been very surprised if that was the population parameter. And in our two-tailed test with an alpha of 0.05, which means you have 2.5 and 2.5 on either side, 95% confidence interval, 5% alpha. Do you see the connection there? But because our p-value was less than that, we rejected the null. Again, because it's outside the confidence interval. Kind of cool. I hope you see that connection. All right, that is a two-tailed test for a one-sample z-test.